Hello, welcome everybody. My name is Tom de Ritter. I'm the CTO of a company called STYLELABS, and I'm going to do a very exciting presentation that unfortunately will be a little bit boring on machine learning because it's how that I learned myself. It's a lot about mathematics. So we'll start going through that a little bit and then go into the fun part, do a live demo with you guys. So if you stick to the end, you get to see a live demo. So machine learning, it's a hot topic right now. It's not just about digital asset management. We're going to check out what we can do with machine learning inside digital asset management. So what is machine learning? So it is, in short, the ability to make computers learn and make predictions. There's a Wikipedia definition underneath it. Well, you read that it's older than many of you here. So it started out back in the 50s. But the computers weren't strong enough back then. So it's taking up now because of a couple of reasons. First of all, computers get stronger. And second, we have much more data. So to be able to make computers learn, there's 4 steps we have to go through. And the first step is we need data. We need a lot of data because it's statistical algorithms that computers will use to get through that data. So just a couple of 10,000 items is not going to be enough. We need millions of rows of data to be able to make good models. So if we have that data, we need to organize it in a way that computers can detect patterns. So we'll probably do a lot of statistical algorithms on that data to see if the computer can come up with some patterns in that data. And if it can, we can build a model out of that, and then we can use that model to make predictions with new data we have. So I've told you that we need a lot of data. So today we do have a lot of data. So every day it's about 2.5 quintillion, I didn't even know what that was, bytes of data are being produced on a daily basis. To put that into something that everybody understands, that's 2.5 million MacBook hard disks written full every day. So that's a lot of data. And in these data, there's a lot of secrets that are hidden. And those secrets, the human eye can't see anymore. So we need machines to go through it and to detect all of that. I'm not going to talk about privacy. Today, it's about getting something to learn about this data. Let's start with a little bit of an example here on pattern recognition. I'm going to give you all 1 minute to try and find out if there is a pattern hidden in these 10 rows of data. Anybody that knows it, raise your hand. Yes?
All they issued and where used, anywhere that's a significant distance apart is going to be flagged as fraudulent.
Yes, but there is something, UK and Germany are close together, so that's a no there.
I meant like opposite sides of the world, like USA and Russia. One of them jumps.
That's one.
They're all copyright Dave Chappelle.
So I'll tell you what it is. If a computer looks at this, it is all credit cards issued in the USA, used in Russia by people in their 20s, above 1,000, with a transaction above $1,000 is going to be the right answer here. So you need a couple of minutes and you can figure that out. But now imagine that there's 10 million rows of this. It's going to be a lot harder to get through this. So we're using statistical modeling to look to this problem. And you all know what statistical modeling is. Maybe some of you had some statistics in the past. Let me go through some of them. The simplest model we can think of is a regression analysis.
Is there a difference between machine learning and applying an algorithm, or is that?
It's part of the machine learning process.
Okay.
So applying an algorithm is number 2. Once you have the data, you apply an algorithm to find out if there's any patterns. And if you find those patterns, you put it inside a model so that we can use to make new predictions. So the idea of this table is if you find an algorithm, then we can build it into a model, and then each credit card transaction that we see, we can run live against that model and it will tell me if it's fraudulent or not. I just had this yesterday, that I paid for something and it came up as fraudulent, and I immediately got a call from the bank to check if this was actually me here in New York paying something. So it's live detected based on all of the data they have in their systems and based on the model they're actually using. So and what they'll get is a number between 0 and 1 whether something is fraudulent or not. So and then it remains a business decision to see whether you actually go through with it. If it's 80% fraudulent, you might say, okay, we're not going to let it through. If it's 50%, you might want to keep the customer at ease, and so there's a business decision after it. It's only guessing that the computer can do with a certain certainty. So we'll look at some of those numbers in a minute. So so first of all, getting the data in there, and then second, finding a statistical algorithm to see if there's something to be found inside that data. And a regression is one of the algorithms that is a lot used inside machine learning, and it tries to find relationships among variables. So on the right hand, we see there's the quarterly change in GDP related to unemployment, and so we can see if we allow a machine to look at this, that there is indeed a relation. It's a line that if the change in GDP is higher, then employment goes up or down. So that's something that a machine learned. Maybe you could have guessed that yourself, but that's something it learned. So imagine this amount of data be sitting in pictures, for example, with all colors related to each other, and then machines try to find patterns if something is grass, or if something is a building, or if something is a human being. So that's way more advanced than just finding a regression between these two variables. So the outcome of running all of these algorithms is going to be a model. And this model eventually is what we then use in our daily business to ask questions: is this transaction fraudulent, yes or no? So a lot of work goes in front of actually having this model. So I've put it all in a row again for you. David Chappelle did. There's raw data, first, that we have sitting everywhere, and we need to munch that data. So there's a lot of, we call them data scientists, needed to make sure we get the right columns, because the age might not be important in the transaction. It might be something else. These credit card companies, they have millions of fields on us, and so we have to check out which fields actually apply the best to build the best algorithm, to build the best model. So first of all, there's data pre-processing and data munching that we have to do. Then, and this is an iterative thing, obviously. After we have all of our data, we can actually build a candidate model out of it if we find the right algorithm, and then also improve the algorithm a little bit. And then if we have the best algorithm, we can finish up our model and then publish that model to our applications to be able to use. So a couple of critical steps. First of all, we need to get our data right. Second of all, iteration is going to be key to get the best algorithm translated into the best model. And then last but not least, because you get something out of that model, you still need to understand your business, because in the end, a percentage will be a business decision to make. Some of the example applications that we know today are fraud detection, but also spam filtering. Spam filtering uses a lot of machine learning algorithms to make sure something is or is not spam, and they're getting better and better by the day. People of you that use Gmail will see that it's actually doing a very good job. There's OCR, Optical Character Recognition. So what is that? We can detect text in pictures. So that's also something that is learning, auto-learning. Search engines use a lot of machine learning. Can somebody give me an example of why search engines would use machine learning?
Like the results from Google will always populate what's the most relevant and useful for you.
Yep. Unfortunately, relevancy is something that machine learning is not so good at, and Google has proven that they don't use machine learning for the relevancy. They use machine learning for a lot of other stuff, for the ads that they will show you, but not for the relevancy, because people can trick Google too much otherwise if they just use the machine to build the relevancy. And so that's why it was in my head also the most obvious decision, but it's not. So it's used for showing ads next to the search results. Okay, so that's machine learning. So now if we apply all of this to digital asset management, is this something we can see a future in? So first of all, what big data do we have in our DAM? So I've told you that we need a lot of data to be able to help machines learn something. So what's the big data inside the DAM system? Anybody? Pixels. Yes, so the assets and the pixels. Do we have enough of those? How many assets do we need to be able to predict the next asset that comes in? So you'll see that in an average DAM system, there's not going to be enough assets to do something. So we're going to be needing much more. Next to the assets that I've said that we want to use to auto-classify something, there's also analytics. There's user behavior on the DAM, users clicking around, downloading stuff that we might use to recommend downloads to other users. We'll also see that it's not nearly going to be enough in a DAM to be able to do something. You need Netflix scale analytics to be able to give the right recommendations. So what do? We try to use a little help from the internet. Luckily, the internet has many more pictures available, and so if we buy a model from the internet, and there's a couple of companies available. So Microsoft has cognitive services, Google has the Cloud Vision API, and there's a company, and they're called Clarify, that are all delivering generic models and specified models to be able to do machine learning on your assets. And then you can obviously also train and refine those models by sending thousands of assets and then allow human people to check those assets and to train the model for it to do a better job. But so just like that in the DAM, we don't have enough stuff. So we need the help from the internet. So what we can do with images? Images, there's a couple of things we can do. We can do subject detection. So try to guess what's on the picture. Interesting for people that don't like to tag. And we can see that by now, I think 70% of that subject detection is actually making sense. 2 years ago, it was different. It's getting stronger and stronger every month. Last week, Microsoft released an upgrade with a 50% increase in hit rate. So if you follow it closely, it's getting better and better. Color detection, also something interesting. Try to find hotspot colors, background colors, to compare those assets together. Face recognition, something that you all know from iPhoto and those tools. There's two types of recognition. There's recognizing that it's a human and then trying to guess his age and stuff like that, and then recognizing an actual face, trying to see that it's Barack Obama on a certain picture. Sentiment detection, that's fairly new. See if a face is actually angry. And then there's OCR, also looking for text pieces inside of your pictures. You know, in digital asset management system, there's not just images, there's also text. So can we also apply machine learning algorithms on text? Yes, if we feed it a PDF, it can do subject detection. What's this 20-page PDF about in one paragraph? It can do highlighting. It can do sentiment detection on tweets, for example. Is this a nasty tweet or is this a happy tweet? And it can do, and we've all tried that, it can do auto-translation. If you tried Google Translate or anything else, you've seen that it has become better over the years. So it's learning, actually. And that's the last big step that I forgot to mention. If you have your model, the feedback of the real world is an important task to make that model better again and to make the machine actually learn. Video. Video is actually just a bunch of images put in a certain sequence. So there's now patterns to be found in the sequence itself, temporal sequences that detect anomalies. For example, a camera in your house and there's a burglar coming in. So that's something that a video detection system would be able to recognize. Okay, we're going to do a little shootout here on the three systems. So I've prepared a couple of images first, and then we're going to run them through the different classification engines to try and guess the tags, to try and get the OCR out and detect the subjects before we go into the live demo. So the first shootout I had is this pulled pork. I don't know if it's a slider or larger thing, but it's certainly delicious. Delicious is something that Clarify got right. If you look closely at the results, it's a bit, they're all off a little bit, and they all detect different things. So Microsoft is the only one that actually has a sentence also. They try to guess what's on the image in one sentence, so they say a close-up of a sandwich on a plate, which is pretty accurate. Then they say it's table food, indoor sandwich, food a second time, and then it's cooked. Google and Clarify don't have sentences, but they have food, dish, meat, and you can see it. I have a little bit more there. I stopped with Microsoft everything that goes under 50%. I didn't put it out there, so it's just the top 50%. Then there's Clarify, and they go a little bit off. I think it's a dairy product. I don't know if that's right. And then it's refreshment. It's a refreshing sandwich. Not sure if that's correct, but we can all see if we upload this to the DAM and we let it chew on it, we can at least find it back on a number of tags, right? So without us having to do something. OCR, Optical Character Recognition, trying to see what text is on this picture. So Google missed an O there, exit NLY. It didn't get the O right. Microsoft got the O and got the text correct. It's not a, maybe in another picture it's different, but it's something I noticed here. So it can actually detect signs and stuff like that. And this is used heavily in cars. For example, Tesla cars, they use cameras to look at speed limits, to make sure that you're doing the right speed, and warn you if you're not. So that's OCR in video then. Another nice one, face detection. So both Google and Microsoft can get the face out of the picture by drawing something on it, so that's not interesting. But then there's the sentiment, and so they both have a different way of approaching things. So in Google you can see that it's possible that there is some an angry likelihood, if that's an English word. The angry likelihood is possible, and all of the rest is very unlikely. Microsoft, they look at everything between 0 and 1. Don't be mistaken, there's a 1.1 there, but it has E-7, so this means you have to shift the numbers to the right with 7 digits. So it looks like disgust, 71%, is pretty accurate here. So that's a good thing. We're gonna do some live uploads later, but I first want to go into the second part that I thought was interesting. It's recommendations. How can we recommend stuff to other people based on what people were downloading? And so we did a test actually. We've built this model, and one of our customers, the largest customers we had, we asked them for 3 months of log files. And we built this model, which is based on the Matchbox algorithm. This is Azure machine learning, by the way. And so we built a Matchbox algorithm, we fed it the data, and then we looked at what recommendations people were getting, and it wasn't good. So 3 months of data of a large company, and we're talking 10,000 DAM users, 2,000 unique users downloading stuff every day, 3 months of data, not good enough. So we're gonna try and refine this, and maybe next year I'll be here again, and then we might have something useful. But up to now, it's worthless. People will not be able to look at this. So this is something that we really need big data on, and you will see that even on Netflix, the recommendations I get are also I think a bit lame. It's not really what I'm looking for. So it's based on how you looked at the cartoon pictures, so it will serve you 7 more cartoon pictures. So I think there is improvement to be made there, and the more data we get, the better we can make it. Okay, dog and pony show. So I've just taken our solution here, and just right now I downloaded a couple of pictures from the internet. I haven't looked at them. I've just put them in, and so we're gonna see together what was found out. So we've integrated with Microsoft Cognitive Services here to do 3 things: face detection, subject detection, and OCR. So let's see if it actually got something out of it. Computer analyzed data. You can see there's a lot of stuff coming back. So it's not adult content, so that's good. It's not racy. It detected grass with a confidence of 99%, and a pen, and then there's everything here. So grass, food, sitting table, bag, plate, bowl, filled fruit. It's a bit strange, and it's a bowl of fruit sitting on a grill. It's a bit strange, but if you look at it, you can see why it thinks that it's a ball of food sitting on the wheel, because it's the skewers have some vegetables on it, and so that's maybe why. So tomato is actually a fruit, so I got it right. I had something interesting this morning. I'd like to share that with you because it's this guy here. This was actually my wild card. So this is Mark Davey playing baseball. It says a close-up of a person holding a baseball bat. And what you people don't know is that in the UK, baseball bats are actually the size of a cigarette. So, yeah, because we don't know the sports, we only see it on TV, we don't know the real size, right? Well, I actually cut that picture a little bit, so maybe there's a... Person indoor spectacles, clothes, accessory, goggles, sunglasses, so interesting stuff came out of there. So I uploaded also a couple of guys here. So there's 3 faces on there, and it's trying to detect the age, 56, 58, and 58. We'll have to figure out the position of the rectangle to see who's the youngest here. Tim can usually do that very fast. If you look at left.
Left is at top, and middle is at the bottom, and right is... So Putin is 58.
Almost 55. I don't think that was...
And they're both 58, yeah.
That's not recent, is it?
Probably not, not anymore.
I'm not sure if it's publicly disclosed.
So it's, again, grass, outdoor, suit, clothing, man, standing, posing, dressed, necktie, and clothes. A group of men standing next to a man in a suit and tie. There's no ties here. Yeah, I'm doing this deliberate to, let's see what it thinks of this here, a picture of the Hilton. A city street filled with traffic at night. That's pretty accurate, right? I had something else. Let's upload the competition. Where did I put this? Yeah, this has some text in it. Drop it in there. And then we're gonna have to wait, so if my internet works, it will reach out to the engine. First it needs to create a smaller version, because we don't want to kill the Azure service by giving it 100 megabyte pictures. Obviously it will not accept it, so we create a smaller version of it and then we send it. Anyway, I've tried this picture before and it does detect the open text words on it, so that's good. Alright, I think that kind of concludes this session, and I'd like to know if there's any questions here on the topic.
Am I to understand that the first part of your demo at the end was your own technology, your own machine learning, and it's competing with the machine learning technology of Google and Microsoft?
No. At the end, so we are not a machine learning company, we just use one of the algorithms, and the one that we use is the Microsoft algorithm, so we've integrated that. So they expose this as a service, and you pay per time you do a request, and then you can use it in your own system.
Can anybody just log into their view?
Yeah, so there's a, that's maybe interesting to show. So there's a demo site here. If you would go to Microsoft Cognitive Services, and then it's called the Computer Vision API. And so this is the URL, microsoft.com/cognitive services computer vision API. And you can play around yourself here by uploading a couple of pictures and see what it's actually doing. Other questions?
I'll ask a wildcard question. What do you think the arc of sophistication is for this sort of technology? Like, is it do you predict it will someday free us from ever having to tag images?
I used to laugh with this last year. I'm not laughing anymore now. So what I've seen in the last couple of weeks is an accuracy improvement of over 50%. So it's getting stronger and stronger, and people are on it. But it's only the big companies that are going to be able to do it. So either you're going to need a lot of venture capital, like probably Clarify, or you're going to have to be one of the big guys to be able to do this, because it's not just a simple thing to do.
There's a German company called Bosch, I guess you know it, this machine. They built it up to analyze all the machines. So if you buy a professional machine, you can scan it, and after it's archived in your system. And if you need a spare part, for example, you can scan it again, and it identifies the broken part.
So they probably did a lot of training to be able to detect anything. There was a gentleman. We still have time?
I'm just curious about the difference between AI and machine learning. I know machine learning through auto classification systems that you use for auto tagging insurance and subject. So I'm just curious what the difference is and where they can.
That's a bit of a tricky question. I think artificial intelligence is more something that we try to see, where we try to mimic humans in machines. Like a robot that is actually detecting, that can interact with us, while here we train the machine to do one specific task of one specific model in a specific prediction. So it's a different thing.
I think certainly it's the difference between using predictive analytics algorithms and artificial intelligence relies on actual just basic learning. So machine learning is really about adding that level of predictive analytics on top of that.
All right, we're out of time. Thank you all. Enjoy the rest of the day.